When it comes to enterprises and businesses, adapting to AI agents is not an easy decision to make. Let me tell you why. I've been working with customers in financial and banking domain, and there are so many constraints when it comes to adapting to AI agents. Lots of data that is used within the internal team, it is confidential data, be it banking statements, policy documents, or invoices that is being extracted. You can't use any closed source large language models. The customers think twice before you send it across Gemini, Claude, or any closed source large language models. This is where multiple experimentation is run within the internal team to use open source large language models. And also recently, Google released their new open source model called Gemma-3n. Gemma-3 is a lightweight large language model that can be used in the edge devices like IoT or mobile devices. It is also multimodal, where it can process video, audio, and images, and you can also use it for multilingual tasks. And I've already shared one video on Gemma-3 where I've told you when it comes to Gemma related models, the native touch of using language translation is very useful. This is where in this video we will cover 3 use cases that you can build using open source large language models such as Gemma-3n with Ollama. And I will also show you how you can extract structured responses from an agent using Agno and also Ollama. So let's begin with this video. Before we can proceed with code implementation, I just want to share you some updates. We have completed the MCP tutorial series, and we've also started with project series on retrieval augmented generation, large language models, and agents. And meanwhile, if you have not yet checked those videos, do check it out. We have some live sessions coming out. And don't forget to subscribe to the channel so that we can bring more such videos. So let's begin with the code implementation. Let's begin by setting up Ollama on Colab so that we can utilize free GPU. In order to use free GPU on Colab, what you can do is you can select runtime, then click on change runtime type. And now what you can do is you can select T4 GPU, which is available for free of cost. Just for this video purpose, I'm using L4 GPU so that I can get quicker responses that I can show it to you. But you can use T4 GPU. Why? Because Gemma-3n is a lightweight LLM model that can also run on just 15 GB of VRAM. So once you select T4 GPU, you can just click on save. And now what we have to do is we need to install Ollama. And once we install Ollama, we need to serve Ollama model within the Colab instance. Now, Ollama whole purpose is to run large language models locally. But Ollama is not running within your own system. It's running on Google servers. So in order to run that within this particular instance, you can use nohup, which is mainly used for no ang up. It's a Linux command. And once you run this Ollama serve, if you want to execute that endpoint within the Colab instance, you can just use this particular command. Now what we will do is let us install Ollama. And once we install Ollama, we just have to serve that particular model so that we can utilize any models from Ollama library. So these are all the models that is supported. You have DeepSeek R1, you have Gemma-3n, which we will be using in this video. Then you have Gemma-3, Qwen-3, and there are so many open source models that are available over here. So now let's just select Gemma-3n, and here it is available in 2 different variants. One is Gemma-3n 2 billion parameter model and 4 billion parameter model. It also mentions the size of it. As you can notice, 7.5 GB is more than enough when it comes to using T4 GPU. And this model, if you want to use it, there are 2 commands. The first command is you have to pull the model. Once you pull the model, you have to run that model. So what we will do is, let's come back to the Colab. And now that if you notice, you have the endpoint. Ollama API is now available at specific localhost, and then 11,434 is the port. So this is running locally, but you want this to run on Colab instance so that you can get the responses. This is the reason why we are redirecting it. Now let's install Ollama so that you can pull the model. So let me delete this. And also we will be using Agno, which is an agentic framework. This is mainly utilized for the use cases that we will be building to use the agent object. Alright, so now that the installation is done, as I mentioned, we need to do 2 steps. First thing is you have to pull the model, and once you pull the model, you have to just run it. And in order to pull, I'm just using Ollama.pull Gemma-3n E4b. So this step is gonna take around 1 minute, and once it's done, we will proceed with the use cases implementation. As you can see, it took around 57 seconds to load the model. Let me zoom this a bit. This is the 57 seconds which it has taken. Now what we will do is we will start with our first use case, which is multilingual agent, which is nothing but your language translator. Alright. Now, whenever it comes to building an agent, you have to give certain instruction and role play. This is what we call as system prompt. So system prompt is basically you define the role play that a agent needs to adapt to. It's giving certain controllability, and then you are also defining instruction, which is nothing but the boundaries that you have to define to the agentic framework. So let me paste the prompts which I've already copied. So this is the system prompt. You are a professional translator and native speaker who provides accurate, culturally appropriate translation while preserving the original meaning, tone, and context. Based on the given target language, translate the user query. So this is the variable that I need to define. And there are also some instructions that we have defined so that if the source language is not specified, you can detect it properly, and it should also maintain the original style. It's time to define the agent, but before that we have to import few statements, which is from agno dot agent. We need the agent object, and then we also need the Ollama model. From agno, I need Ollama as the model. I will import Ollama. Alright, so now let's define our agent, which is translator agent, and we will define the agent object. So the model is nothing but Ollama, and you have to give certain ID. So ID is basically the model that we are using, which is Gemma-3n 4 billion parameter model. Now we also need to define the system message. System message is nothing but the translation system, and then we also have instructions equals to translation instructions, and whenever I get the response, it should be in markdown format. So I will just define markdown to be true. And if you want to give more flexibility to your agent, you can also define the role is nothing but expert translator. Alright, so you have role, you have model, you have system message, you have instruction and markdown. So this is all you need to define your agent using agno. And now what you can do is you can use a user query. You can paste any message of your choice. What I will do is I will come back to Ollama page. I will copy this information about Gemma-3n. I will come back here and I will just paste it. So you have some information about Gemma-3n, which says that it is efficient execution on everyday devices such as laptops, tablets, or phone. These models were trained with data in over 140 spoken languages. This is the reason why we are using it for language translation. And one thing what I've observed with Gemma models is that it's very good when it comes to native touches. Most of the large language models, they have very limited tokens when it comes to different languages. It's very good with English, right? But some languages is very important. Whereas if you look at Mistral model, it is a French or France based model. It's very good with European languages. When it comes to Gemini or Gemma related models, it's very good with Indic languages, right? So what we will do is we will define a target language to be something which is Indic. I'll just use Hindi. You can also try with any European languages. We'll also test that out. And now what we can do is let's just run this. Let's run our translator agent dot run, and then I'll just define this inside response equals to translator agent dot run. Here just pass the user query. Just pass the user query inside a f string, and then tell it translate to target language. So if you notice the system prompt, you have target language variable, paste that here, and then define your input variable, which is nothing but target language. And once you have the response, you just have to run print response dot content. So if you see, we got the response in the language translation, then it has also given the explanation on whatever responses it has generated. Well, let's also try with different language. Let me give French. Alright, it has also given the response in French. But again, when it comes to language models, they are very good with translation. No doubt about that. And now it's time to proceed with the second use case. This use case is very important when it comes to running your open source models locally. And this is nothing but invoice processing, where it's a multimodal use case plus structured responses for an agentic workflow. So first thing is, we will be using multimodal workflow to understand what is within the image, and then we will also be generating the response in JSON. So this is where we will be utilizing structured responses from Agno itself, where we will just define the pydantic base model and then connect it with our agentic workflow. So now what we will do is, let's define our pydantic model. Let's define the pydantic model. I've already defined it. Let me get those instruction. So in order to use image, I've just defined from agno.media import image, and then to define the structured responses, I will be using pydantic base model and field. So these are just the data type that I will be defining for my JSON keys. And now what I'll do is, I'll define the base models. Now let me get this. The first thing is line item. Whenever it comes to invoices, there are multiple line. You have description, you have quantity, you have unit prices, you have total prices. And then when it comes to invoice data, you have vendor name, you have vendor address, you have vendor email, then you have client name, client address, and whatever you have defined in the line item, you also want that inside a list. So if you notice the other items, these are nothing but a string, but when it comes to line item, it's a list which is being used from the line item. So this is the base model or a structured response that I want to get from a Agno agentic framework. All right. Now let's define the agent, which is invoice agent. The procedure is same. We need agent. So the model will be same, which is Ollama. ID equals to, it was Gemma-3n E4B. Now we need system message and instruction. So I also have the system message and instruction ready. So let me get those to you. And this is one of the projects that I've been working on. So it's the same prompt that I've been utilizing. You are an expert invoice processing assistant that extracts structured data from invoice image with high accuracy. And in whenever it comes to system prompt, if you are defining different instruction to the LLM model, make sure you are defining it within the markdown or XML format. So here I'm utilizing XML format. You have extract and extract. So these are the details I need to extract. And what are my requirements? I've also defined the requirements inside the XML tag. And then the output needs to be in JSON format, which is again in XML format. So this is my system prompt. And I also have certain instructions that I have to provide. So instructions are extract vendor information from top section, then identify table boundaries for line items, validate mathematical accuracy. Most of the time, language models will not calculate the invoices. It might be tampered. So it's better to validate it. And if there is any information which is not relevant, you have to flag those as well. And then handle multiple languages. Again, we know language models support different languages. If there is any invoice which is in different language, I don't want LLM to restrict it. It should understand that language and generate the relevant response. All right, so this is the system prompt and instruction. So let me define those. You have role play. Role is very important. I'll just write expert invoice analyzer. Then you have system message equals to system prompt. And now instead of markdown, what I have to do is I have to define response model. So we'll define response model to be invoice data, which is already defined over here. So if you notice, this is the base model, pydantic base model, where we are generating the JSON format, which is vendor name, vendor address, vendor email, client name, client address, and line items. Since line item is a list, we have another base model for that, so that we maintain certain consistency. So just copy this voice data, define that in the response model, and then just tell use JSON mode to be true. So instead of markdown, I'm using JSON mode. All right, so this is my invoice agent. In order to use this invoice agent, I'm defining something called as from agno.media import image. So this is a multimodal agent. So for that, what I need to do is I need to upload a image path. So I already have a basic image for invoice. So now what I'll do is I will just upload one of the invoice that I have. So let me rename this as invoice PNG. And if I have to open this, you have some invoice from garden repairs, and you also have certain cost, and this is the line items. So if you notice, these are the line items, and then you have bill information where you have client name and address. So this is the example that we will be passing. Just define the once you upload the data, copy the path, add it here, and now what you have to do is just define the media. Let me define the response. Response equals to invoice agent dot run. Here what you have to do is you have to define images equals to a list of image, and you have to define file path equals to image. So notice it's the same syntax what we have used earlier. Earlier we used translator agent dot run, then just directly give user prompt. Since it is a multimodal use case, instead of prompt you can also give prompt. Let me also define a prompt. I'll extract the details. So now I'll just define this response, and once you have the response, you just have to run response dot content, and now we have the response ready. It took around 14 seconds, but let me remove this print statement, and we have our information inside invoice data, which is the object. Then you have all the details that we have defined inside the pydantic base model. But if you want to get the actual information, what you can do is, let me define invoice data variable, and then after content just define model dump, so that you can get the dictionary. Now if I print this invoice data, it's in dictionary. You have vendor name, vendor address, vendor email, then you have client name, client address, and then all the line items. So this is how you can define a structured responses within the agentic workflow. How? Using pydantic base model. And once you define your pydantic base model with proper keys and information, you can directly give it inside response model, and then make sure you define use JSON mode to be true. This is very, very important. All right. Now what you have to do is, we are proceeding with the last use case of this video, which is nothing but generating BRD documents, which is business requirement documents based on the user details or user requirements. So this is business business requirement document, and this is mainly report generation use case. The process is same. We need the system prompt, we need instruction, and then we have to define the agent. I have the prompts ready for that. Let me copy this. When it comes to generating BRD documents, usually it's a very lengthy process. It takes too much of time in order to generate this BRD from business analyst. So if you look at the role plays that we had, for translate we had translator, expert translator. For invoice extractor we had invoice analyst. For business requirement document we have business analyst. So define the role play, define the instruction, and then run the agent. And as I said, when it comes to BRDs, defining the format of the BRD is also very important. You have lots of subheadings. So if you notice, when it comes to BRDs, you need executive summary, you have project background, you need business objectives, scope and boundaries, stakeholder analysis, functional requirements, then non-functional requirements, data requirements, integration requirements. So this is the table of content. So when you are building this application, and if you have the UI, you can tell user to add their requirements. Once they add their requirements, you can have second field which will take the template. In what template do they need the document to be in? And once that is done, this entire is the template. So if you notice the BRD prompt, it is a you are an expert business analyst and technical writer, so that you can craft it, who creates comprehensive business requirements document that clearly define project scope, objective, and functional requirements. And once this is done, make sure whatever template you are adding here, it is depending on your company data or what you follow based on the best practices, right? So let me just run this, and the parameters are BRD system prompt, BRD instruction. So let me create a BRD agent equals to agent. It's the same thing, model equals to Ollama. ID is nothing but Gemma-3n E4B, and then you have to define your system prompt. And if you notice the role, it's nothing but senior business analyst, and the output, it is better to have it in markdown. So I'll just write markdown equals to true. And now what you have to do is the prompt that you have to pass to the BRD is something that a client will define. This client requirements will have different information. What is the timeline of this project, and what are the stakeholders and other important details. So I have one dummy information which I've created. So this is the client requirements. You have client requirements that it's a new customer support chatbot system, which was my first agent tutorial playlist series. You can go check out that video, which is related to how you can build your customer service chatbot. And you have some information about the company. Then what are the features or functional requirements of the chatbot? Then what is the budget and success metrics? So based on this, you have to generate a BRD requirements. So this is the client requirements. And now I'll just write response equals to BRD agent dot run. I'll just define client requirements. That's it. And then once you have the report, I will just run response dot content. But instead of using response dot content, it's better we use something called as IPython. I'll use IPython. Okay, you got the autocomplete. From IPython.display, import display and markdown, then use display inside that markdown, and then response.content. This will generate the entire BRD in the markdown format. So this is going to take some time because it's a very lengthy response that it will generate. So as you can see, you have the very lengthy response. So this is the business requirement document for the chatbot. You have some information, then introduction, purpose, scope, target audience. So target audience is mainly the stakeholders. So this is how the initial draft of BRD looks like, and open source LLMs can be used for this kind of task. Now that we have completed 3 use cases, that is translator agent, then invoice extraction, and BRD generator, I have an assignment for you. And this assignment is the giveaway assignment. Here what you have to do is you have to pick any one of the use case, either from retail, which is nothing but inventory management, or you can pick something on the legal, which is something related to finance analyzer. If you pick any one of these use case, and if you share this on social, whether it is LinkedIn, Twitter, or Instagram, if you tag me, I will pick top 3 winners, and I will be sending you a swag box which will contain some surprise, right? So this requirements is you have to share this particular video, share this video, which is nothing but Gemma-3n use cases, and then you have to attach your GitHub URL of any one use case, whether it is retail or legal. You have to attach with a proper readme.md, and you also need to have app.py. Either you have to have Gradio or Streamlit UI, and then you have to share this on LinkedIn or Twitter, and you have to tag me. On LinkedIn, my ID is Tarun R. Jain, and on Twitter it is TRJ0751. Don't forget to attach your GitHub URL, and let's see who wins this particular giveaway swag. And this is it from this video. If you enjoyed it, don't forget to subscribe now. More such videos are coming soon. Thank you so much for watching till the end.